Hi students, in the last class you have seen how to find the inverse of a matrix. Now let us see its applications. Now it has many applications. One of the applications is solving system of linear equations. Now let us see what we mean by linear equations one by one. First, so that we can consider an example, that is cost of a pencil and 2 pence is rupees 10 and the cost of 3 pencils and 2 pence is rupees 14. Then what is the cost of pen and pencil? Well, we need to find the cost of pencil, each pencil and each pen. We need to find. Okay. Yes. Now these type of problems already we have done in 10th standard. See, cost of a pencil and 2 pens is rupees 10 and the cost of 3 pencils and 2 pens is rupees 14. Then we need to find the cost of each pencil and each pen. How do we find? For that, first of all, we have to form the linear equations. We have to form the equations. How to form? Here, which is unknown? Cost of a pencil and the cost of a pen. These two are unknowns. Therefore, we can let them as x is equal to cost of a pencil. Cost of a pencil. Now let us assume y is equal to, that is, you can take it as rupees x and rupees y equal to cost of a pen. Cost of a pen. Now we don't know what's the cost of each pencil. We have taken as x rupees. Then cost of each pen we have taken as rupees y. With the help of these unknowns, we can form equations based on this given data. Now here, cost of a pencil, one pencil. The cost of a pencil is x. You can take cost of a pencil is x. And cost of 2 pens. Cost of 2 pencils. The cost of each pen is x. 2 pencils you can say what? 2y. Now, sum of these two equal to rupees 10, you can see. Now we have formed the first equation. Likewise, by data, the cost of 3 pencils. Cost of a pencil is x. 3 pencil cost you can take 3x. And 2 pens means 2y. Cost of these two things, which is equal to rupees 14. Now, we have framed the linear equations. We have framed the linear equations. Why we are calling these equations linear equation means here the variables are x and y. You can call them as unknowns here. X and y are two unknowns. Here also we have x and y are two unknowns. All these unknowns are having degree 1. Therefore, these three equations are called linear equations. The equations which are having degree 1 of their variables is called linear equation. Therefore, here these two variables are having these two equations having the variables x and y, each has degree 1. Hence, these two are called linear equations. If you consider these two set, these two as a set, this is called a system of linear equations. We can call them a system of linear equations. System of linear equations. Now, after that, we have to find the values of x and y. Means we have so many methods already we have learned. These two equations can be solved by using elimination method or substitution method or cross multiplication method. All those methods we have studied in 10th standard. Now we can go for a new method called matrix inversion method. Before that, let us see how to find the solution. Already I have found. Suppose you find the solution for this one by any one of these three methods. That is a method of elimination, method of substitution or cross multiplication. If you solve them, you can get x plus 2y equal to 10 means you can add. There is x plus 2y is equal to 10 and 3x plus 2y is equal to 14 means now we can solve these two equations by elimination method. Now here these two coefficients are equal, then we can eliminate easily by subtracting. Subtracting means you have to change the sign of these two things. You can now x minus 3x gives 2x. These two getting cancelled means you can say x equal to 2. X equal to 2 we can say. Now if x equal to 2, we can get y value by substituting this value in any one of these two equations. X equal to 2 means 2y equal to 8. Therefore y is equal to 4 you can have. Therefore now these two are the values of x and y. That is cost of a pencil is rupees 2, cost of a pen is rupees 4. Now these two values x value and y value will satisfy these two equations simultaneously. These two values of x and y will satisfy these two equations simultaneously. Therefore these equations are called system of simultaneous linear equations. System of simultaneous linear equations. Now this is one of the method. Now we can go for another method called matrix inversion method. Let us see how to see. Now the values of x and y which satisfies these equations is called what? A solution of the system of linear equations. Solution of the system of linear equations. The values of x and y which satisfy the system of linear equations is called solution of the system of linear equations. Okay, now let us see first matrix inversion example. See here you can consider a11x plus a12y is equal to b1. Then you can take second equation a21x plus a22y is equal to b2. Now let us assume these two is called the system of linear equations of variables x and y. These are called as a system of simultaneous linear equations. Now these two are called the algebraic equations. Now these equations can be converted into matrix form. For that, let us see here first. These x and y are variables and a11, a12, b1, a21, a22, b2. These two are simply constants. Here the variables are only x and y. Now we are going to separate. Now even though a11 and a12, a21, a22 are constant, they are multiplying with this variable. Hence they are called coefficients. Therefore, just you separate the coefficients, detach the coefficients. We can say a11. Here a12, first equation, then second equation a21, this is a22. Now with these coefficients you form a matrix. This matrix is called coefficients matrix. Now after that, just here what are the variables means x and y. These variables we can write in column matrix. Now left hand side, now is equal to again right hand side b1 and b2 are two constants. This also you can write as a column matrix. Now if you multiply these two matrices, you will be getting these two equations. See here, row by column method a11x plus a12y equal to b1, first equation. If you take the second row, a21x plus a22y equal to b2, you get the second equation. Therefore, this is algebraic form, this is matrix form. Now we can say this as a matrix equation. We can call this as matrix equation. We can call this as a matrix equation. Now this is particular case, we can generalize it. Now the matrix which can be obtained with the help of coefficients is called coefficients matrix. That can always be taken as capital A. You can take A. Since these are variables, a matrix which is having variables can be denoted as a variable matrix. You can take it as capital X. which is equal to, since b1 and b2 are constants, these constant matrix we can take it as b, that is ax equal to b. A is called coefficients matrix, x is called a variables matrix. The matrix B is obtained with the help of this constants in the right hand side of the equation. Now we can say ax equal to b. Now this is called matrix equation. This is called a matrix equation in general form. Now here the aim is to find the values of x and y, this matrix x. From this matrix equation we need to, x means we have to eliminate a. This a is in the first left hand side of x, means this a can be eliminated using its inverse by multiplying, that is pre-multiplying. Therefore to eliminate a we can pre-multiply by a inverse, pre-multiply by a inverse. Therefore we can write here a inverse into a, which is equal to a inverse into a into x. You are pre-multiply left hand side. A inverse into a into x is equal to, again pre-multiply by a inverse b. Yes. Now if you consider this one, we know very well matrix but is always associative. Therefore we can associate these two first. A inverse into a gives always an anti-matrix of order n into x is equal to a inverse b. Now we know very well, if you multiply any matrix by the anti-matrix, you get this same matrix. We can get x equal to a inverse b. X equal to a inverse b. Now this is the solution for this matrix equation. Now here x means nothing but this one x, y, these two variables, which is equal to a inverse, means we can find this inverse for this matrix. That is what a inverse into b you can write. Now this is another matrix by equating the corresponding elements and the values of x and y. Now the method of solving by this method is called matrix inversion method. Now let us see how to find the solution by using matrix inversion method. Now we are going for exercise 1.3. In between exercise 1.2 is there we have to find the rank of a matrix, that we will see after completing this application of inverse. Now let us see the exercise 1.3. The first problem is given here. First problem, first subdivision given and the page number 33. That is, solve the following system of linear equations by using matrix inversion method. The first problem is 2x plus 5y equal to minus 2. The second problem is x plus 2y equal to minus 3. Now this is the first problem, first subdivision of the exercise 1.3 given in the page number 33. In our material this is problem number 42. Problem number 42. Now here these two equations we have to solve by matrix inversion method. Now first of all we have to write these equations in matrix form. The matrix equation is the matrix equation is, just detach the coefficients. You can write 2, 5, then 1, 2. Now this is coefficients matrix. Into the variables are x, y. The variables are x, y. Now which is equal to minus 2, minus 3. Now this is of the form a x equal to b. Ax equal to b. Now this is called what? A matrix equation. Now with this we have to find the value of x, means we have to use the formula x equal to a inverse b. But before that let us see what is a. A is nothing but 2, 5, 1, 2, and matrix x is xy, matrix b equal to minus 2, minus 3. Here you can write where capital A is equal to 2, 5, 1, 2. And the matrix X is XY column matrix, and the matrix B is also a column matrix, that is minus 2, minus 3. Now, we are taken separately, but for all these problems, you need not write this step, you can go directly. Now here, the matrix equation Ax equal to B means the solution is X equal to A inverse B. X equal to A inverse B. Now, here we want to use this solution means we have to find A inverse. A inverse means this A must be non-singular. Therefore, we can directly do the steps here. First, you can find A inverse, then we can obtain here. See, here, want to find A inverse means A inverse is equal to, already we have seen 1 by determinant A into adjoint A. 1 by determinant A. Determinant A means 2 2s are 4. 2 2s are 4 minus 5 gives minus 1 into its adjoint. Interchange the linear diagonal elements and change the sign of anti-diagonal, minus 5 minus 1. Now, which is equal to, that is A inverse equal to, this 1 by minus 1 is minus 1. Take inside, you can get a minus 2, 5, then 1 minus 2. Now this is A inverse. Now this can be applied here. Now here X is nothing but, this X matrix is nothing but X, Y you can write. You can just replace. Equal to, what is A inverse? Minus 2, 5, 1, minus 2. Into the B matrix is minus 2, minus 3. Minus 2, minus 3. Yes, just you multiply these two, you will get the solution which is equal to minus 2 into minus 2, 4, then plus 5 into minus 3, minus 15, then can multiply this one, 1 into minus 2, minus 2, then minus into minus plus 2 3s are 6. Now if you simplify, you can get X, Y matrix. So is equal to 4 minus 15 equal to minus 7. 2 plus is equal to 4. Minus 2 plus is equal to 4. Therefore, the solution is X equal to minus 11 and Y is equal to 4, you can say. Or this can be expressed in another form, that is X comma Y. X comma Y is equal to minus 11 comma 4. You can use either this method of presentation or this one. You can use any one of these two. Now these two equations, these two values minus 11 and 4 will satisfy these two equations simultaneously. Therefore, by matrix method we can find the solution with these steps. Okay, now here first once again I will tell you, these are the given equations in algebraic form. These equations can be rewritten as a matrix equation by detaching the coefficients, first called coefficient matrix, then we write what variables matrix, then the right hand side constants matrix. Now this is of the form Ax equal to B. Ax equal to B form you can say. Now if it is Ax equal to B, the solution is X equal to A inverse B. Before that we can find A inverse. A inverse equal to 1 by determinant A into adjoint A. We got minus 2, 5, 1 minus 2. Then we can use this formula to find the solution. Just you are replacing X matrix, A inverse and B. Then we are simplifying. Finally, we got the values of X and Y which are satisfying these two equations. How do you check your result means that already you know. These values can be substituted in any one of these two equations. You check whether you are getting RHS or not. For example, let's take the second equation, X plus 2y. X equal to minus 11 plus 2y means 2 into 4, 8. Minus 11 plus 8 gives what? Minus 3. Hence, these are the correct values. These are the solutions which are satisfying these two equations. Okay, let us see the next problem. Likewise, you can do first problem, second subdivision given at the page number 33 and example 1.22 given at the page number 31. Now, these two problems are very similar to this previous problem. Therefore, you can take